All right, for this one, vertical asymptote done the same way. Set the denominator equal to 0, and you wind up getting x equals 2. So that part's pretty easy. Now the other one you have to look at, guys, this one's kind of tougher. If it is top heavy, which means the degree is bigger, which this is x squared over x, what is my horizontal asymptote? None. You don't have one. Okay, but make sure that you put none on the test tomorrow. Don't leave it blank. Now, when you graph this, you will only see part of the graph. That is not the entire graph. Okay, now you got to zoom out a little bit. Just know that if you only see one little piece, and let me show you again what that kind of looks like. If you graph it, you can tell it's working up here in the corner, and when it finishes this, it's still working. Okay, that means it's doing something else somewhere else. So zoom out. So zoom 3, and then hit enter, and you'll be able to see the rest of it. There's the part we saw, and there's the other part. Okay, so when you do this, guys, you may have to change your scaling. I'll try to do that on the test for you tomorrow. But to the right of my error sign are these bigger numbers that I can't plot. So I'm going to change my scaling on my y-axis to 2, which means if I go up, it's going to be 2, 4, 6, 8, 10, 12, 14, all the way to 20. Okay, so I'll try to do that for you tomorrow in case this happens. But to the left of the error is 1, 0, which is right here. 0, 2, which is right there, since my scaling is increments of 2 now. And then negative 1, 2, which is right here. I could probably do one more. Negative 4, 0 right there. Okay, so my graph looks like this. And it goes off diagonally to the left forever. Then do the same thing to the right of the error sign. So 3, 14. Let's see here, 4, 12, 5, 12, and I think the next one's going to be 8, 14. It does the same thing. There's your graph. Now, I'm not going to ask you for a range because it's difficult to find, but your domain is all real except x cannot be 2. That's it. So again, you can change the scaling of just your y. You don't have to adjust the x's. I just changed my y scaling to 2. That's just to help me so I can see the whole graph. All right, this one, when you graph it, you'll notice the shape that it has, and my calculator is still zoomed out from the last problem, so I can't even see it. So zoom 6 fixes that. It's got that bell curve shape. Okay, it's kind of a small bell curve, but it is there. So when you do this, to find the vertical asymptote, we usually set the denominator equal to 0. But when you do that in this problem, you wind up taking the square root of a negative. Those are imaginary solutions. So you can't solve it. There are no real solutions. So there is no vertical asymptote. Okay, if this was an x squared minus 2, then you can solve it. Or an x squared minus 4. But there's a plus sign there in between those. It's going to get you imaginary. What is the horizontal in this case? Y equals 0. If it's bottom heavy like it is here, remember the last question we did was top heavy. So there was no horizontal asymptote. This one is bottom heavy. There's an x squared on the bottom, and then even there's no x on top. That means it's always going to be y equals 0. Okay, so your horizontal asymptote is right here. There is no vertical asymptote, and then all you do is go to your table of values and plot the points that you can plot. And I always start off at 0, since that's usually where these bell curves kind of symmetric are at. So 0, negative 1, and I can do, I can do negative 2 and negative 1/3 and 2 and 1/3. I can do those two. So about right there. Do the best you can. I know it's kind of hard to see. But your bell curve looks like this. It's flat. It goes up, down, and then becomes almost flat again. But it is always increasing. It's just increasing towards 0. Okay, it does increase infinitely, although it's kind of hard to believe. It's just increasing infinitely towards a certain number. Okay, it's always approaching 0, but not ever reaching it. Now, my domain for these, for any bell curve you have like this, is always all real. Okay, if it's a bell curve shape, it's always going to be all real. Now, you're going to need to pay close attention to the range. This is the one that very few people get on the test correct. Okay, this is a compound inequality when you set this up, because my range is in between this lowest point on this bell curve and then in between the horizontal asymptote. Okay, so you have to set up an inequality that states what it's doing. So my y, which is what my range is, can be, let's start off with my horizontal asymptote. It's below that horizontal asymptote. So less than 0, but not including 0. But then it's also greater than that lowest value of -1. So greater than or equal to -1. Now it can be written that way, or you can also have these things flipped. You can say it's greater than or equal to -1 and less than 0. That's fine as well. It's the same thing. All right, guys. For this one, last graph from 8.3, we'll start off with a vertical asymptote. Set the denominator equal to 0. Now there's two ways to solve this. You can factor it and then solve it, or you can just do the square root method, which I think is easier. Add the 4 over, square root both sides to get rid of the squared, and you get plus and minus 2. So in this case, you do have two vertical asymptotes. You got one at +2 and one at -2. And you can kind of tell that from the graph. It's got two places where it's going down forever. So +2, dotted line, and -2. All right, the degrees are the same. We've seen this before. The degrees are x squared over x squared, which means that your horizontal asymptote is going to be the leading coefficients, which in this case is -1 over +1. So y equals -1 is your horizontal asymptote. And that is right here. All right, from there, all you do is you plot the points that are in between the error signs, plot the points that are on the outside of the error signs. Your error signs should be at -2 and 2. And they are. So in between them is going to be that U shape at 0, 0, 1 1/3, which is about right there, and -1 1/3. Just do the best you can. It's kind of hard to do with fractions. But your U shape looks like this. And for this problem, all my other points are fractions, so I'm just going to plot 1 on both sides of it. I'm going to do -4 and -4/3, which is about right here. And I'm going to make my curve like my graphing calculator had. And on the other side, the error sign is the same thing, but on the opposite side, 4 and -4/3. Sometimes all you can do is a couple points because of the fractions. So your domain for this is really easy. Kind of running out of space here. All real, but x cannot be positive or -2. Your range is not that simple. Okay? There is a gap, if you look at it, in between the bottom of this U shape to the horizontal asymptote that we cannot include. Okay? So we've got to set up an OR compound. It's everything above that U shape or below the horizontal asymptote. So y can be greater than or equal to this 0, 0. Or y can be less than my horizontal asymptote, which is at -1. That's another question that very few people get completely right come test time.